Hello and welcome to SudoKanard. I recently published a different Sudoku puzzle on Logic Masters Deutschland under my other, one of my many identities on the web, and this one is Modouin. It's my identity on Logic Masters Deutschland, and here it is. So the logic to solve it is a bit tricky. I mean, obviously you can bifurcate your way through the puzzle, but I want to show that it can be solved logically, and it's not easy. So even if I've already solved it several times today, I might be a bit slow to notice what lies in the puzzle. Now, about the rules. The classic Sudoku rules apply, so every digit from 1 to 9 should be in every row, on every column, on every 3x3 block, 3x3 box. And there are those circle digits, which are each time the difference between both digits in those cells. So that's all there is to it. Now, let's get solving. Well, first there are a couple of straight Sudoku logic. Well, those 6 give us a 6 in here. Those 2 give a 2 in here. These ones say there's a 1 either here or there, but if we put a 1 in here, it puts a 3 in here, which is not possible. So there's a 1 in here, and we can pencil mark a 1 in one of those cells. 4 and 4 and 4, we have a 4 in one of those cells. 4 in here would yield a 3 or 5 here. Nothing is impossible at this stage. What next? These 5 give a 5 here or there. So there's a 5 in here. It's not here, so it must be here with a difference of 1, but you can't put a 5 in here because it would need a 4 or a 6 in this cell, and both are forbidden. And so 5 must go there, and the only possibility is with a 4. 1 is not here, nor here nor there, so it has to go here on the second column, accompanied with a 3. And let's complete the column with 7 and 8 to be disambiguated later. Those ones say there's a 1 in one of those cells. Now, what next? 9 is not here nor there. There must be a 9 in here and a 9 in here. No 6 in here, no 6 in here. Should play a role later. No 2 and 5 in here. They have to go somewhere there. And apart from 2 and 5, we need 6, 8, and 9. So 6, 8, and 9 are the only candidates here, not 8 here. So it's 6 or 9 here, 6, 8, or 9 here. No 8 here. 2, 5, and something else. Actually here, what could it be? It can't be 9, so can't be 1, 3, 4, 7, or 9. So in these cells we need 2, 3, 5, and 6. So this is 2, 3, or 5. But with a difference of 1. So if we have a 2 in here, this can't be a 1, so this has to be a 3. This 3 needs a 2 or a 4. This 5 can't have a 6, so it will be a 4. So that's many possibilities. No, that's 2, 3, and that's 3, 2, or 4, actually. Yes, that's it. Now, what can I say next? Is it about this row? Oh, this 6 and this 6, there's a 6 in here. And there has to be a 6 in here. No 2 there. Well, 2 could go anywhere among those cells. No 4 here or there. There's a 4 up there. So what could this cell be? Only 2 or 7. All of the digits are here. Four in this box, 4 must be either here or there. Seven is in one of those cells, not that restricted. About this, we have some restrictions about the digits in this cell. We can't have 1, 2, 4, 6, or 9 in here. So it must be between 3, 5, 7, or 8. But 3 would require here 1 or 5, which are not available, so not a 3. 8 would need a 6, which is not available, so not 8. So this is 5 or 7. 5 can't come with a 3, so it has to be a 7 in this case, and 7 can't go with a 5, so it has to be 9. And the nice thing here is that one of those cells has to be a 7. Therefore, removing the possibility of a 7 in this cell, we know there's no 7 in here, so on this column, 7 must be here. Now we have a 7 here or there. And in this column, we need now 2, 3, 5, or 2, 3, 5, and 8. So this must be 3, 5, or 8. This must be 3 or 5. And 2 must go here or there. Three is either here or there on this row. 5 is not here, nor there, so 5 is in one of those cells. This cell is somewhat restricted. It can't be 1, 2, 3, 5, 7, or 8. What remain? 4, 6, and 9, I think. That's it. 4, 6, and 9. But not 9, because I've pencil marked the 9 in here. So this is 4 or 6. This is restricted as well. Not 1, 4, 7, 8, 9, 5. So the remaining possibilities are 2, 3, and 6. Now, here's some really concealed logic. we know that the possibilities here are 2, 3, 3, 2, 3, 4, 5, 4. Let's have a look at this 4, 6 and at those digits. If we put a 6 in here, then there's a 4 in here, obviously. But if we don't put a 6 in here, then this is 2 or 3. And if this is 2 or 3, then it's not possible to have 2 or 3 in here. Because 2 or 3 down here requires the other 2 or 3 up there. So we can't have, well, what was I saying? We can't have 2 or 3 in here. No, that's not what I meant. If we put 2 or 3 in here, then we can't have 2 or 3 in here, and therefore we must have a 4. So let me recap. Either we have a 6 in here, paired with this 4, or we have 2 or 3, which implies a 4 in this cell, which pairs with this 6. So this 4, 6 is paired with either this 6 or this 4. And this removes the possibility of a 6 in those cells. And with this 6, we know there's a 6 in this cell. Wow. Now that's something. And now comes the logic about 8s. Let's have a look at this row and this row. We know that 8 doesn't go there. So on this row, 8 is either here or there. I mark this way. And on this row, 8 is not here, so 8 has to go either here or there. And this gives an X-wing. If 8 goes here on this row, then it removes this possibility and we now have 8 in here. Otherwise, 8 comes here on this row and here on this row. So in both cases, in both scenarios, we have 8 here and there, or 8 here and there. So on those columns, 8 can't go in any cell other than those. And it removes the possibility of 8 here and there. And now we have only those possibilities for 8. And on this column, we remove this possibility for 8. And this one too. So now, in this box, 8 must go either here or there. And in this box, only 3 possibilities remain. Here, here, and here. That's it. And now that we know this, let's have a look at this column. 6 can't go here. 8 can't go here because of the X-wing. Same in here. 6 can't go here. 8 can't go here because of the X-wing. They can't go there. So we have a 6-8 pair in these cells. 6 and 8 can only go in those cells. It removes this 9. So 9 must go there because of the pencil marks. And this 9 and this 9 give us a 9 in this cell. And now there's a 9 in one of those cells. And what is more, we have the 6-8 pair. So now, to complete the column, we need 1, 3, 4, and 7. This is not a 1. This is not a 3, so this is 4 or 7. On this row, 3 is not there. So now this can't be a 2. And there are still 2 possibilities for this difference of 1. This is not 6 or 8, so the other 6 or 8 must be here. And this is 2 or 5. And here on this row, well, what can we do? So there's a 5 in one of those cells. Now, because of this, oh, in this box, 3 is not here, 3 has to go there. Removes this 3. Yes, 3 is a very difficult number, a very difficult word for a French guy, for a French person, at any rate. Now, we need here, this is not an 8, so this is 6 or 7. For 6, 7, and 5. This is not a 6, this is not a 7, so this is 4 or 5. This is not 4 or 6, so this is 5 or 7. That's it. Are there any chains? I don't think so. I don't remember spotting chains, which does not mean there is none. We need a 6, and perhaps, oh, this is not 6 or 7, no 5, so this must, oh, this 6, gives a 6 here, and this can only be an 8 now. So this is a 5, this is a 7, this is a 9, and this is a 3. That's it. This 9 removes this possibility. Now we have a 9 here by Sudoku. This is a 2-8 pair. This is a 1-5 pair. And this 1-5 solves for this one clue, finally. So these 2 and 3 give a 6 and an 8, and it should all unwind from now. This 4, this 5, this 7, this 6, 8, 7, 8 in here, 7 in here. Now we need 4 and 5 in here. This 5 here, give a 5 and a 4. This now is a 3. 4 is pushed upwards. Not quite sure about the pronunciation. This is an 8. Oh, and this 5 disambiguates this 1-5 pair. Now these must be 2 and 6, and with this 6, this is this way. Now this is a 7. We need 4 and 2. Oh, we don't have the answer yet. These are 1, 3, and 4. Oh, still some ambiguity. 1 and 3, 1 and 4, 3 and 4. 2 and 4. This we need 2, 4, and 1. Oh, this one, this ambiguous. This is a 1. This is 2 or 4, and this one disambiguates the one. Well, those digits. this is a 2, this is an 8, this is a 2, this is a 4, this is a 2. Here, oh, this 2, this ambiguates this. Now these are 4, 5 and 8 this way, 4 and 7, 3 and 9, and that's it. This wraps up, yes, this wraps up a logical solve of this different Sudoku. So the key points were, well, no, this is not a 3, that's wrong. This is not a 6, this is a 3. Well, I deleted the wrong digit, but I'm sure this holds now. Now this is correct, I'm sure. I hope. Well, so the key points were the X-wing on 8, which allowed this 6-8 pair to appear. And this logic, this strange concealed logic about the 4-6 pair that was spread on 3 cells. That's very exotic logic, I must say. Thank you for watching this video, and see you soon, I hope, on SudoKanard.